Hello everyone. Today we'll talk about NCERT Solution of exercise 1.2, 1.5 and 1.6. Exercise 1.5 is a simple exercise of successive magnification method in which we magnify the number line with in between the two numbers to represent the numbers up to 4 5 decimal places. Just have a look for question number 1. Visualize 3.765 on number line. As we know, the 3.765 will lie in between 3 and 4. So if it lies between 3 and 4, we'll signify 3 to 4. That is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.8, and 4. Now, as it is 3.7 to 3.8, it lies between 3.7 and 3.8. We further magnify 3.7 and 3.8. When it magnifies 3.7 and 3.8, it will lie 3.71, 3.72, 3.73, 3.73, 3.75, 76, 77, 78, 79, and 3.8. Now, we can easily identify the 3.765 will lie in between 3.76 and 3.77. We will further magnify it to 3.761, 762, 763, 764, 765, 767, 768, 769, and 3.770. Then further we'll identify that the line this here will have a number 3.765, and we can easily identify the location of 3.765 on number line. So we'll be proceeding to successive magnification process, and after the 3 or 4 successive magnification we get the exact number which was required. Now question number 2 of exercise 1.4 says we need to visualize 4.26 bar on number line up to 4 decimal places. Up to 4 decimal places, it means we need to represent 4.2626 on number line with the help of successive magnification method. So we can easily identify the number will lie in between 4 and 5. Here we'll magnify a number line in between 4 and 5, that is 4.1, 4.2, 4.3, 4.5, 4.9, 5. Further, it will lie in between 4.2 and 4.3. So we'll successively magnify 4.2 and 4.3 in subparts. Further, we can identify that 4.2626 will lie in between 4.26 and 4.27. So we'll further magnify 4.26 and 4.27. Here we'll have 4.261, 262, 263, and so on. Now we require 4.2626. Then we'll further magnify 4.262 and 4.263. When we magnify 4.2620 and 4.2630, we'll have 4.2621, 2622, 2623, 2624, 2625, and 2626, 2627, 2628, 2629, and 2630. So here we have 4.2626, which was the required number to be represented on number line. In this particular point, will represent 4.2626 up to 4 decimal places on number line. In this way, we are done with exercise 1.4. Now we'll start with exercise 1.5 now. In exercise 1.5, we need to classify the numbers as rational or irrational. So a few questions we already had discussed about this exercise. 2 minus 5, as one is rational and other one is irrational, and we know that addition or subtraction of rational and irrational will always give a irrational number. So 2 minus root 5 is a irrational number. Now the next is 3 plus root 23 minus root 23. Here we have plus root 23 minus root 23. In this case, we need to add the numbers, and when we will add the numbers, it will give us the exact value as root 23 and root 23 will get cancelled, and we'll have root 23, root 23 cancelled, and left with root only the number 3 only. So that is 3 is a rational number here. Now we'll have 2 root 7 by 7 root 7. As 2 root 7 by 7 root 7, we can cancel root 7 and root 7. We left with 2 by 7, and 2 by 7 is a rational number in the form of p by q. Now 1 by root 2, 1 by root 2, as root 2 is a rational number, and we know that the division of rational and irrational will always give a irrational number. So the quotient or the final answer will be a irrational number, that is 1 by root 2 is a irrational number. Now 2 pi, as we know that pi is irrational and 2 is rational, we know the product of rational and irrational will always give a irrational number, so 2 pi will always be the irrational number. Further, in question number 2, we need to simplify 3 root 3 into 2 root 2, as this is the two brackets. We need to multiply the brackets inside. That is, we'll first we multiply 3 into 2 root 2, and further we'll multiply root 3 into 2 root 2. So here, in question number 1, we need to multiply this 3 and 2, 3 to the 6. Here we multiply 3 into root 2 and 3 root 3 into root 2. That is, first we multiply this 3 and 2, then we multiply this 3 and root 2. After this, we multiply root 3 and 2, and then we multiply root 3 and then we multiply root 3 and root 2. So in that way, 3 into 2, 6, 3 root 3 into root 2, 3 root 2, root 3 into 2, 2 root 3, and root 3 into root 2, root 6. 3 into 2 is 6, 3 into 2 root 3 as it is, and root 3 into root 2 will give you root 6. Now, all these numbers are unlike numbers, so we cannot be able to solve it further. That will be the final answer now. Now, the next question is 3 root 3 into 3 minus root 3 plus root 3 into 3 minus root 3. So here again we'll multiply, we'll do the same method. 3 3 is a 9. 3 into root 3, 3 root 3 with positive 3 3 is a 9, and 3 root 3 into root 3 will minus 3 root 3 into root 3, or root 3 into 3 will plus 3 root 3, and root 3 into root 3 will give you minus 3. So here this plus root 3 root 3 and minus 3 root 3 will get cancelled, and 3 3 is a 9, root 3 into root 3 is 3, 9 minus 3 is 6. So the final answer for this is 6. In next question, we'll have 5 plus root 2 whole square. In 5 plus root 2 whole square, we need to multiply root 5 plus root 2 whole square. The question was printed wrong. So root 5 plus root 2 whole square, here we need to find out either a plus b whole square, or we multiply the bracket to bracket. So if we need to multiply bracket to bracket, it will be root 5 into root 2 into root 5 into root 2. So if I'll multiply root 5 into root 5 and root 5 into root 2, then root 2 into root 5 and root 2 into root 2, all are plus, and a plus b whole square will give you 7 plus 2 root 10. Root 5 square is 5, root 2 square is 2, 5 plus 2 is 7, 5 into root 2 root 10, and again root 2 into root 5 will give you root 10. We will have 5 plus 2 plus root 10 plus root 10, 5 plus 2 is 7, and root 10 plus root 10 is 2 root 10. In this way, we can able to identify the product of these two numbers. The next part of the question is root 5 minus 5 minus root 2 and 5 plus root 2. This is again a plus b, a minus b, a plus b, a minus b, a square minus b square. 5 square is 25, root 2 square is 2. 25 minus 2 will be the answer, that is root 7. So in this way, we can able to identify the product of two numbers. I'm going to again show you the same screen. So in case of this way, if we need to find the product of two numbers, we'll find it out like this: a plus b whole square, a square b square plus 2ab. There is a plus b, 5 plus 2, 2 root 10, there is 7 plus 2 root 10. And here we identify the identity of a minus b, a plus b. There is a square minus b square. A square minus b square is a plus a square root 5 square 5, root 2 square 2. The answer. Now, the next question says, recall pi is defined as the ratio of circumference and diameter. That is, pi is equal to c by 2. It seems to be considered contradict that pi is irrational because it is in the form of p by 2. How you will resolve this contradiction? So, as I told you before, that pi is c by d circumference upon diameter, but any of this value, either circumference of will be irrational, then the answer will remain irrational. So as we know that the quotient of non-zero rational number will irrational number, or quotient of irrational number will non-zero rational number is always a irrational. If the numbers are rational, either of circumference or diameter will irrational, so it will be irrational only. And in case of this circumference or diameter, any of this one will be irrational. So there is no contradiction, as pi, c or d can be irrational. Hence pi is purely a irrational number. Now we need to represent root 9.3 on number line. So if we need to represent root 9.3 on number line, here we have root 9.3. So first we'll draw a line segment of root 9.3 centimeter. Then we'll extend it to 1 unit, that is 10.3. Then we'll bisect it. The bisector will meet at point O. Now, after bisecting this, taking OS center and OA radius, we'll draw a semicircle. The semicircle will surely intersect, passes through point A and C. From point B, we'll draw a perpendicular. This perpendicular meets the semicircle at point D. The length of this BD will be under root 9.3. Taking B as center and BD radius, we'll cut an arc which intersect the number line at point A, and we'll consider B as 0, C as 1, and the number line starts with point B. So the BE, the length BE will represent root 9.3 number line. Now, this is the justification for the same, as we already discussed during the class. Now we rationalize the denominator of the following: 1 by root 7, as root 7 in the denominator, a single number is in the denominator, we multiply by root 7 in numerator and denominator, and we get the answer as root 7 into root 7, 1 into root 7, root 7, and root 7 into root 7 is 7. So rationalized form of 1 by root 7 is root 7 by 7. In second part of the question, 1 by root 7 minus root 6. As we have 1 by root 7 minus root 6, we need to multiply by the conjugate of root 7 minus root 6, or rationalized factor of root 7 minus root 6 in numerator and denominator. So we'll multiply by root 7 plus root 6. When we'll multiply by root 7 root 7 plus root 6, we're left with root 7 plus root 6, and the denominator, which is 7 root 7 minus root 6 into root 7 plus root 6. This is a plus b into a minus b, that is root 7 square minus root 6 square. Root 7 square is 7, root 6 square is 6, 7 minus 6 is 1. So we're left with root 7 plus root 6 upon 1. And the answer is root 7 plus root 6. Now, let's move on to the third part of the same question. We have